we're doing choosing the appropriate statistical test or procedure, I guess I should say. We're talking about one sample or two samples. So we're talking about everything that you've learned up to this point. So we're talking about the one sample Z interval for P. We're talking about the one sample Z test for P. We're talking about the two sample Z interval for P at P1 minus P2. The two sample Z test for P1 minus P2. We are talking about all of our mean stuff. So our mean stuff, we have our one sample T interval for mu, we have a one sample T test for mu, we have a paired T interval for mu difference, we have a paired T test for mu difference. We have a two sample T interval for mu1 minus mu2, we have two sample T test for mu1 minus mu2. I'll probably use more of the written names like I used in the notes, but don't use the calculator speak. Most likely these would be kind of multiple choice questions anyways, so you probably won't be writing it out, but in this particular one we're going to write things out. Alright, so here we are. We basically have choices here. You would need to consider how many samples you have. So you have one or two samples, and if you have one sample, it is possible that it is paired data. So I might say like a paired t-test or a paired t-interval. The other thing you need to think about is, are you dealing with a proportion or are you dealing with a mean? And then the last thing you want to think about is it an interval or is it a test? If it's an interval, you're trying to estimate something. You're trying to come up with a value for what the parameter, so what mu or p could be. If it's a test, you're basically just trying to answer like a yes or no question. So yes, it could be this, or no, it can't be that. You're not really trying to come up with a number or anything. So let's do a couple of them together, and then I will have you pause the video and you can try them on your own. So, do teens drive faster on the freeway than the general public? Currently, the general public averages 68 miles per hour on the freeway. A random sample of 200 teens was observed. Alright, so again, I can see right here there's only one sample. They're talking about a quantitative value, so they're not counting anything. Remember, your proportions are categorical, your means are quantitative. So it's a mean. So I've got a one sample, it's a mean. There's no pairing going on. Then the question is, am I just trying to answer a yes or no question, or am I trying to estimate something? So they want to know, do they drive faster? So is it yes or no? So this just ends up being a one sample T test for a mean. The next one, it says, are oysters that grow under natural conditions more likely to form a pearl than oysters that are farmed? 4,000 natural, 3,000 farmed oysters. So we have two samples. This one's categorical. You're just trying to figure out pearl. Yes, is there a pearl or is there not a pearl? And then this one here, we want to know, are they more likely to form a pearl? So we're just not asking how much more likely, we're just asking yes or no. So it's a test. So this one is a two sample Z test for a difference in proportion. This is the one. So I think in the book, when I just showed you that chart, it said a two sample Z test for, so instead of writing it like this, they said P1 minus P2. So this like piece right here was replaced with that. So if you want to write it like that, that's fine. But that's what it is. It's a difference in proportions. The next one, again, let me emphasize this again. If it's a proportion, it's Z. If it's a mean, it's a T. That's just pretty much how the College Board, that's how your book rolls. Does meditation lower stress? The average stress level is 42. 87 people who meditated, average 38. What can be concluded? All right, so this one here, does it lower stress? So again, it's a yes or no. It gives us an average here. we have a sample, a one sample, so this is just a one sample t-test for a mean. Are men more likely to stop their car and assist a woman with car troubles parked on the side of the road? So we have two samples here. We got male drivers and female drivers. They either stop or they don't stop. So it's a categorical, so it's a proportion. I'm just going to count how many people are stopping, how many people aren't stopping. So I'm going to compare the two proportions. And then I'm just going to see, are the men more likely to assist than a woman? So is the proportion of men greater than the proportion of women? So again, what we think about is we think about taking the difference. So this is just a two sample z-test for a difference in proportion. Let's see here. Okay, this one, it says how much faster. So right there, you're looking for an estimate. You actually want 2 minutes or something as your answer. You are timing people. That's a mean. You have 40 men and you have 30 women. You have two samples here. So this is a two sample t interval, because again, it's an interval. I want how much. I want an estimate for a difference in means. And again, this one, what they would have said in the book, instead of doing this, they would have said mu1 minus mu2. Let's look at number 9. So 85 people were observed to see how many seconds they spend brushing their teeth and how many seconds they spend brushing their hair. Estimate. That tells you right there, interval. The average tells you right there, it's a mean. Okay. These people were observed and they were doing two things. So one person is going to have a time for brushing their teeth and one person is going to have a time for brushing their hair. So this is a matched pair. So this one, we would say it's a paired t interval for a mean difference. And real quickly here, I've probably mentioned this before, but when you're doing a paired test or paired interval, it says it's for a mean difference. When you're doing a two sample, we say difference in means. What happens with your paired data is you have two scores for one person. Again, maybe this is teeth and this is hair. And what you do is you subtract the two and then you come up with the difference. And then you find the mean of those differences to test something about the true population difference. When you're doing your two sample stuff, you have maybe one group, so the male swimmers, their speed, and then the female swimmers, their speed. You don't take the difference first. You find the means, and then you subtract the means. So it'd be to try to figure out something about the difference in the population means. So here we did the subtraction first, then we find the mean. Here you find the means, then you do the subtraction. So that's why they're different. Okay? All right. I want you to take some time, finish 6, 7, 8, and then do the ones in the back. Pause the video, because then I'm going to go over the answers. And if you're just copying down the answers, you're not learning. All right, 6. What % of new calculators are defective? So defective, not defective. Got one sample here. They want the percent. They want an estimate. So one sample is the interval for a proportion. A new treatment is being tested to see how much more effective it is in curing people with the Ebola virus. The old treatment has a 34% success rate. 55 people affected with Ebola were given the new treatment. This is a one sample Z interval for proportion. Average weight, woman in their 50s is 135. You're interested in seeing if this weight is different. Is it just different? Yeah, I suppose you could probably do an interval for this one, but I just looked at it, yes or no. They want to know if it's different or not different. You weigh 71 women, so you've got a one sample T test for a mean. On the back are more crimes committed during the daylight hours compared to the night. Police get records from 200 consecutive days. All right, there's one sample of 200 days, but you're recording two things from those 200 days. You're recording the crimes during the daylight and the crimes at night. So it's a paired t-test. You just want to know, are there more for a mean difference? 0.1% of pine trees will fall. This year, 10,000 trees that were given a new fertilizer were tracked to see if fewer of them would fall down. This one, again, are we less than that or not less than that? So one sample Z test for proportion. Average age of the voting public greater than 40, 2,000. So one sample, average age, is it greater than 40? Yes or no? So one sample t-test for a mean. This one here, so it's 45 customers, so there's one sample, but you're recording two things: the amount of money they're spending on the main course and the amount of money they're spending on other items. So you're looking at that paired T interval. You want to know how much paired T interval for a mean difference. Traffic Friday afternoon compared with Saturday afternoon, 2 separate days. So 40 randomly selected Fridays, 40 randomly selected Saturdays. You are doing a 2 sample T interval. How much for a difference in means? This one here, it depends on how this one's not very clear. The original source I got it from intended it to be a paired, but I can understand why it reads as a 2 sample. So I was reading it as the visitors, it's the same visitors, and they came one time, rated it, and then they came to another time and rated it. So it would be a paired T interval. If you're reading it as 2 separate visitors, it's a 2 sample T interval for a difference in means. Then, do wives spend more money on non-essentials than their husbands? 90 couples were observed. So it's a paired T-test for a mean difference. So the wives and husbands are a couple. That's why it's considered a paired. There is some independency there. Medical researchers tracked 10,000 non-smokers and 9,000 smokers over the next 5 years in order to estimate how much more likely smokers are to die compared with non-smokers. So it's a 2 sample. We got 2 groups here. How much more likely? So it's an interval, a difference in proportions. 1 sample here. What percent? It's an interval. Z interval for proportion.